Okay, cool. I was fiddling with it. I wasn't really sure if it was working. What's up, guys? I just wanted to throw this video up. Today we're going to be going over explain how electrons are distributed in atoms and how this affects the number and types of bonds that can be formed. So I have my notes here. I'm going to be referring back and forth. Sorry about the sun, but we have a window facing at this point west. You know what? This window does not. This window faces south, actually, because the sun's always there. It's ridiculous. But yeah, so if we got the crazy light going on, I was going to try to maybe show you my notes, but I might just have to just grab stuff. Okay, trying to wrap this one up quick. These things take forever to upload, so I'm trying to get it up. I'm going to try to make it like a 10-minute video, try to shoot through it all really, really fast. Okay, so starting off, electrons move around the nucleus in 7 designated areas. These areas are called shells. The first shell holds 2 electrons. The second and all subsequent shells hold 8, up to 8 electrons. Based on like what it is, it will let you know like how many electrons are where. Atoms become stable when their outermost shell is filled to capacity, right? So that's when an atom becomes stable. I even drew little pictures, but I can't show you. Anyway, yeah, so that covers that. I have a picture of a neon atom and a nitrogen atom. And so the only when atoms have electron vacancies in their outermost shell are they likely to interact with other atoms. So that's a good thing to know. It's actually, I believe that's one of the questions straight up from the quiz, which I've been studying because I got my final tomorrow. I'm not sure when you guys did it, but yeah. So when an atom's outermost shell is not full to capacity, bonding occurs in an effort to fill their outer shells. Like I really enjoy this aspect. I've enjoyed biology so far. That light's killing me. It's like in and out, in and out. It's crazy. Yeah. I've enjoyed that aspect so far. It's just really fascinating. It's really cool. Like it's damn near magic. You know what I mean? I guess technically at one point when we were when we looked at it that, I mean, it still is, honestly, if you want to be romantic about it. It's friggin' magic. It's really cool. Anyway, a covalent bond. 2 atoms share an electron. So you have an electron that is missing one atom, an electron missing another atom, and they combine. Technically, you can do this multiple times, but they combine to become to share those atoms, right? Ionic bonds transfer rather than share electrons. So an ionic bond will have an extra electron, and that electron will transfer to another electron. In this case, I have a picture. See it? I'm going to roll the dice as you can. But yeah, so I have a picture of sodium and chlorine. It's a salt atom. I actually took it straight out of the book. But sodium drops its one outer shell electron to chlorine, creating okay, I guess I lost my thought mid-sentence there. Oh, no, okay, so this is weird. Anyway, I broke it. Creating sodium, I guess I didn't, actually. Anyway, the extra electron makes the chlorine an ion. An ion is a atom whose electrons are either higher or lower than its atomic number, so that its number of protons in its nucleus. The extra electron makes the chlorine an ion because it's not supposed to be there, basically, right? Like it's atomic number, all that jazz I just said. The sodium is lacking what it's supposed to have, so it becomes an ion. That's how I broke it down. So this has more than it should. This has less than it should, right? Excuse me, less than it should. And then therefore it's an ion, because of, I already mentioned. Just you got it. I'm sure you got it. So sodium becomes a positively charged ion, and chlorine becomes a negatively charged ion. These actually have names, and if you give me a second, I did not write them down, but just because when I shoot these videos, I like you to know what I'm talking about. Or I like mentioning stuff we haven't learned yet, or may not. So a cation or a cation, maybe, I don't know. It doesn't say. It doesn't really have. And then an anion. So a cation is a positively charged ion. I'm gonna go with that pronunciation. That kind of sounds like how they would say it, and just based on movies and smart people. And an anion is a negatively charged ion. Yeah, so that's the names of them. Sodium becomes a positively charged ion. Chlorine becomes a negatively charged ion, and they are attracted to each other and form a salt compound, right? That's the last one. Okay, so hydrogen bonds. This is the last little get down. Doing 6 minutes. This might not take 8 hours to upload. That's a good thing. You guys don't understand. I love doing these videos. It's actually something I've discovered I like doing. I might do like a podcast or something like that. I don't know. Interview friends. I got a lot of interesting friends. I figure like whatever. I'm a pretty good talker, so maybe it'd be something that'd be fun to try to do, or like a video journal or something. I don't know. Anyway, but yeah, so this is the last one. Anyway, what I was saying, they're a pain in the ass to upload. Excuse my language. But yeah, they're absolute pain to upload. Like every one I do has taken from my house has taken like 8 to 12 hours to upload. So, and like the last one I did was like 25 minutes long. I can't forget what it was about, but so this one I'm trying to cap at 10. I have 3 minutes. I'm gonna get back to it. Hydrogen bonds are based on the attraction between positive and negative charges, right? They're 1/30th as strong as covalent bonds. I know that because I read it in the book and wrote it down. The covalently bonded molecule size differentiation causes electrons to spend more time on one atom than another. This gives certain atoms certain slight charges, which is to say, if you look at my picture right there, I took it right out of the book. Basically what it is when these atoms are sharing electrons, the electrons end up with another atom longer than they do other atoms, which gives, in this case, I didn't write down what these atoms are. It's water, hydrogen, and oxygen, I'm guessing. Hydrogen and carbon, I'm not sure. I didn't take chemistry. But yeah, so these atoms, as they're being shared, they're doing their whole like little and then they're right? As they're being shared, there's actually a video of it on our book site, so if you want to watch that. But as they're being shared, they're spending more time some places than they are other places. So those certain places, as we were talking about earlier with the cation and anion, they're developing certain charges that may change and switch, right? They're said to be polar. That's the word they use. What did I write there? Attract. I write in cursive, and sometimes I scribble it down. And attract other polar molecules and line up so that the positive regions of the molecules are near the negative regions of the other molecules. So this happens. This is known to happen in water. I believe it was nitrogen, carbon, other molecules will form these little bonds, and then you end up with like that's where water kind of gets its way from. Is like they're breaking and changing as things affect it, and these little bonds break, and you're getting that capacity. That blows my absolute mind. When I was in Hawaii, I surfed a shitload. I dove a shitload. Yet again, sorry, a lot. And I sailed and did all these other things, and it's just crazy that like the whole function of water, the whole natural idea of a wave, and it's all possible because of bonds. But yeah, so I'm sitting at 9:45. I killed this. All right, well, I hope that helps. It's been fun to study with you guys and learn with you guys, and I've really enjoyed this class so far. But yeah, good luck on the quiz. All right.